Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2023, Paper 2, Variant 2. In the last two videos, we have already discussed from question 1 to question 4, means we have discussed all questions about mechanics in the last two videos. And today's lesson, we will start from question number 5, and question 5 is about waves. Then we will discuss about electricity, and finally we will also discuss about radioactivity. It simply means that we will cover all the remaining questions from this paper in today's lesson. So this lesson is very important because most of the time students they struggle with waves, and today's lesson is very important to improve your understanding of waves and polarization. As always we will discuss these questions in detail so you can improve your conceptual understanding of AS physics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 5, part A says, a progressive wave travels through a medium. The wave causes a particle of the medium to vibrate along a line P. The energy of the wave propagates along a line Q. Compare directions of lines P and Q if the wave is a transverse wave and if the wave is a longitudinal wave. So first of all, for transverse wave, imagine that wave is traveling to the right. So this is direction of wave, or we can say this is direction of energy transfer, and this is represented by Q. Now imagine that we have a medium particle, and this medium particle, due to transverse wave, this will be vibrating up and down, means it will go up and it will go down. So this is represented by line P. Question is asking us compare directions. So simply if you look at the angle between these two lines, angle is 90 degrees. It means these two lines are perpendicular to each other. So simply we can say perpendicular. So these two lines are perpendicular to each other. So we can say perpendicular to each other. So the angle between them is 90 degrees. Now if you look at longitudinal waves, again imagine that we have a wave, longitudinal wave. This is moving to the right. So this is direction of wave. So this is represented by Q, and now we can imagine that we have a medium particle. So here we have a medium particle, and this medium particle will vibrate to the left and to the right. So this will vibrate to and fro in this direction. So this is how particle will vibrate. So now if you look at these two lines are parallel to each other. So simply we can say these two lines are parallel to each other. So simply we can say parallel to each other, parallel to each other. So these two lines are parallel to each other. So this is what we need to write down, and here we have P that is perpendicular to Q, and here these lines are parallel to each other. And this question has 2 marks. If you have written these 2 points, you will get 2 B marks. Part B says a tube is closed at one end and a loudspeaker is placed near the other end of the tube as shown in figure 5.1. The loudspeaker emits sound of frequency 1.7 kHz. The speed of the sound in the air in the tube is 340 meters per second. A stationary wave is formed with an antinode A at the open end of the tube. There is only one other antinode A inside the tube as shown in figure 5.1. So we have one antinode here and we have another antinode here. For this question we need to determine wavelength of the sound. Wavelength of the sound. We have the frequency, we have the speed. So simply we can write down lambda, this is equal to V over F. So we have value of V that is equal to 340 meters per second, and the frequency is 1.7 kilohertz. And now if we solve this one, we will get our answer up to 2SF 0.20 meters. So the answer is 0.20 meters. So this is how you can answer. This question has 2 marks. So the first mark you will get if you have written this formula, you will get 1 C mark, and the second mark will be the answer mark. For the second part, we need to determine the length capital L of the tube. But for this question, it is given to us we have antinode at one end and then also an other antinode is given. So at the closed end there must be one node, and halfway between these two antinodes there must be another node. So halfway, so at this point there will be another node, so we can also label this one is node. So here we have antinode, so the amplitude is the maximum, and then amplitude has to be 0 here, and then amplitude has to be maximum here, then again it has to be 0 here, and then we can sketch amplitude here has to be maximum, it has to be 0, and then it has to be maximum at antinode. So this is the rough sketch how the wave inside this tube will look like. In order to answer this question, we also need to understand the distance between consecutive node and antinode is equal to lambda by 4. So here we have antinode and also we have node. So the distance between node and consecutive antinode is lambda by 4. So here we have node and antinode. So this distance is also equal to lambda by 4. So simply we can say in this case L is equal to 3 times lambda by 4. So we can write down 3 by 4 times lambda we have already calculated, that was equal to 0.20. Now if we multiply this one, we will get 0.15 meters. So this is value of L. L is equal to 0.15 meters. So if we got the right answer, we will get 1 mark. Third part says the maximum wavelength of the sound from the loudspeaker that can produce a stationary wave in the tube. So we need to determine the maximum wavelength, and maximum wavelength is possible when we have antinode at the open end and we have only one node at the closed end. Now if we sketch the stationary wave, it should look like this. So it should look like this. It's just a rough sketch, not very good looking, but at least it can give you some idea how you need to sketch the first harmonic in this tube. So it should look like this. So this is how you need to sketch. So this is the maximum wavelength. So in this case you can see we have only one antinode and we have only one node. So the distance between these two consecutive node and antinode has to be equal to lambda by 4. So simply we can say in this case L is equal to lambda by 4. So from here we can say lambda max, this has to be equal to 4 times L, and value of L we have just calculated, that was equal to 0.15 meters. So if we multiply this one, we will get 0.60 meters. And this question has only 1 mark. If you have got the right answer, you will get 1 A mark. Part C says two polarizing filters are arranged so that their planes are vertical and parallel. The first filter has its transmission axis at an angle of 35 degrees to the vertical, and the second filter has its transmission axis at an angle alpha to the vertical, as shown in figure 5.2. Angle alpha is greater than 35 degrees and less than 90 degrees. A beam of vertically polarized light of intensity 8.5 watts per square meter is incident normally on the first filter. For part C1, show that intensity of the light transmitted by the first filter is 5.7 watts per square meter. So for this question, first of all, it is given to us this light is vertically polarized. Here we have first of all vertically polarized light, so we can draw this arrow here. So we have vertically polarized light. We can also say the intensity of this one is I naught, and I naught is equal to 8.5 watts per square meter. And for this question we need to determine intensity I1, transmitted intensity. So simply we can write down Malice's law. I transmitted means I1, this one has to be equal to I naught cosine square theta, and theta is the angle between two filters, between vertically polarized light and between this first filter. So the angle between these two, this is the angle between vertically polarized light. So we have vertically polarized light, and the angle here we have 35 degrees. So angle between these two. So in this case simply we have I naught first of all, that is 8.5, and we have cosine, and theta in this case is 35. So we have 35 degrees and square of this. And if we solve this one, our answer should be equal to 5.7 watts per square meter. So this angle you have to take between transmission axis of first filter and vertically polarized light. So means this one is our transmission axis now, and the light is vertically polarized. So the angle between these two we have to take, and then we need to take square of that angle, cosine square of that angle, and we can find out our final answer. So in this case, this is our final answer, and this question has only 1 mark, so this one has to be a mark. Second part says the intensity of the light transmitted by the second filter is 5.2 watts per square meter. Calculate angle alpha. We have already discussed this intensity is I0, and here we have intensity I1, and I1 we have just calculated in the first part. I1 was equal to 5.7 watts per square meter. Now we need to find out value of this angle alpha, and alpha is the angle from vertical. So we can draw first of all another arrow here. This arrow is representing angle of 35 degrees. So this angle is 35 degrees with vertical. We can say this angle is theta. So in this case, alpha, this will be equal to theta plus 35 degrees. So now simply we need to find out value of theta. In order to find value of theta, we can write down I2. So here we have intensity, transmitted intensity I2. This one has to be equal to I1 times cosine square theta. Cosine square theta. I2 we have, and I2 is equal to 5.2 watts per square meter. Now simply we need to plug in values, and we can calculate value of theta. I2 is 5.2, I1 is 5.7, and here we have cosine square theta. So from here we can write down cosine square theta. This will be equal to 5.2 divided by 5.7. Then we can take square root on both sides. We will get 5.2 divided by 5.7 root of this one, and from here then we can determine value of theta. Theta will be equal to cosine inverse 5.2 divided by 5.7 root of this. So if we solve this one, we will get theta is equal to 17 degrees. So alpha from here will be equal to 17 plus 35 degrees. So the final value of alpha has to be 52 degrees. So this is how we can answer this question. And this question has 2 marks. If you got the right answer, if you have got this right value, and if you have got this right value, you will get 2 marks. Question 6 part A says the current in the lamp decreases. State and explain how the resistance of the lamp changes. For this question, it is given to us temperature of the lamp decreases. If temperature of the lamp decreases, it means speed of electrons also decreases, because electrons have less kinetic energy. As speed of electrons decreases, it also means that the number of collisions between ions and electrons also decrease. It simply means that resistance of the lamp decreases. So simply we can say as temperature decreases, resistance also decreases. Temperature decreases, resistance also decreases. This is true for filament lamp. This question has only 1 mark, and this should be B mark. Part B says a cylindrical wire has length capital L and resistance capital R. The total number of free electrons contained in the volume of the wire is capital N. Each free electron has charge small e. The potential difference between the ends of the wire is capital V. Determine expressions in terms of sum or all of the symbols for the current in the wire. So for this question, it is given to us, we have a wire. So you can just imagine this is one wire. and current passing through this wire, we have to determine the current passing through this wire, and the resistance of this wire is given to us, that is equal to capital R. And if we connect a voltmeter across the ends of this wire, the value of PD is also given to us. So value of PD we have, that is equal to V. So we need to determine value of I. So I simply is equal to the potential difference across the ends of the wire divided by the resistance of the wire. So that's all what you need to write down. And this question has only 1 mark. If you got the right answer, you will get 1 mark. Pretty straightforward question. For the second part, we need to determine the average drift speed of the free electrons. So simply we need to use transport equation. I is equal to NQVA. We need to determine the average drift speed. So we can make V the subject. So this is equal to I divided by NQA. But if you look at the given informations, it is given to us that we have the volume of the wire, and we have the total number of free electrons in the wire, and each electron has charge E, and we have the total resistance of the wire. So I, first of all, we can write down I, we have already determined. So I is equal to simply V divided by R. And we have N, so N, we can say that N is the number of free electrons per unit volume. So we have the total number of free electrons, total number of charge carriers divided by volume of the wire. So this is the number density, and Q in this case is equal to E. So we left with A, cross-sectional area of this wire. Cross-sectional area of this wire means the volume V. This has to be equal to the cross-sectional area of the wire times the length of the wire. So simply we can draw. So this is our cylindrical wire. This is like a cylinder. So we can imagine its cross-sectional area is A, and the length of the wire we have, that is equal to capital L. So A, from here we can write down, this is V divided by L. So this is over A. Now simply we need to plug in these values and we can get the answer. So we have I, first of all, I is equal to V divided by R. So this is. Then we have N. N is equal to capital N divided by V. And we have A, that is equal to V divided by L. And we have Q. Q is equal to small e. Now we can simplify this one. Now simply we need to simplify. So this V we can cancel with this V. So we left with, here we have V. This is the potential difference. This is volume. This is also volume. So we can cancel, but we cannot cancel. So we can write down V divided by R, and this is divided by, we have N times E, and this is divided by L. So if we simplify this one, we can say this is V divided by R capital N E, and here we have L. So this is the average drift speed. And so this is our final answer. Simply you need to understand I is equal to which quantities, N is equal to what, and A is equal to what, and then simply put in transport equation, and you can find out value of drift speed. And this question has 2 marks. If you have got the right answer, you will get 2 marks. Third part says determine the average time taken for a free electron to move along the full length of the wire. So first of all, we can simply draw this one small cylinder, and this small cylinder is representing wire, and the length of this wire is given to us, that is equal to capital L. And for this question, we can also imagine we have one tiny electron at this face of the cylinder, and how long this tiny electron will take to reach the other end of the cylinder. So we need to determine the time taken. So we can say delta T. This is what we need to determine. But for this question, we have already determined average drift speed of free electron. That was equal to VL divided by, we have R capital N E. So now we have distance, we have speed, so time delta t simply will be equal to distance divided by Vd, speed. So we can write down, we have L and this is divided by VL divided by N capital RE. So from here we can cancel this L with this, so we left with capital N capital R E divided by the potential difference. So this is our final answer. So this is time. So if we have value of capital N, we have value of capital R, we have value of E, and we have value of PD, we can determine the time taken by a free electron. And this question has only 1 mark, so if you have got the right answer, you will get 1 mark. Question 7 part A says a battery of electromotive force 9.0 volts and negligible internal resistance is connected to a light dependent resistor and a fixed resistor as shown in figure 7.1. The LDR and fixed resistor have resistance of 1800 ohms and 1200 ohms respectively. Calculate the potential difference across the LDR. So this one is our LDR, light dependent resistor. We need to determine the potential difference across LDR. So we can say this PD is V1. So if you look at this circuit, imagine that current I naught is coming from the power supply. So this is the total current in the circuit, and current passing through this LDR is also the same. So we can compare I total, this is equal to the current passing through LDR, and total current in the circuit, we can simply say the EMF divided by the total resistance in the circuit, that is equal to 1800 plus 1200. One has to be equal to V1 divided by the resistance of this resistor, that is equal to 1800 ohms. Now we need value of V1 from here, so V1 simply will be equal to 9 times 1800 divided by 1800 plus 1200. So if we solve this one, we will get V1 is equal to 5.4 volts. So the final answer for this question is 5.4 volts. So a beautiful way you can answer like this. Most of the time we remember that is resistance of LDR divided by R total resistance in the circuit, and this is only true if resistors are connected in series, multiply by EMF of the power supply, means V0. Simply you can understand I is the same, total current is equal to the current passing through the LDR, so we can equate these currents and we can derive this one. So this is our final answer. This question has 2 marks, so you will get 1 mark if you have written this one. That one has to be the C mark, and the final mark you will get, that is answer mark, and if you have got the right answer, you will get 2 marks. Part B says the circuit in A is now modified by adding a uniform resistance wire XY and a galvanometer as shown in figure 7.2. The length of the wire XY is 1.2 meters. The movable connection Z is positioned on the wire XY so that the galvanometer reading is 0, means the reading on this galvanometer is equal to 0. We need to calculate length XZ along the resistance wire. As reading here is equal to 0, it means that the PD between XZ, so we can draw voltmeter here, PD across XZ is the same as PD across LDR, and PD across LDR we have already determined that was equal to 5.4 volts. So it means reading on this one is also 5.4 volts. We can also imagine a voltmeter that is connected. We can connect here. Let's say this is V0. This is connected between these 2 points, X and Y. And the reading on this voltmeter has to be equal to 9.0 volts. As there is no current in this wire, it means the current passing through XZ is the same as the current passing through XY, means current in this whole wire is the same. Current is the same. So simply we can say current passing through XZ, this one is equal to current passing through XY, as no current is entering from this branch. So the current across this one we can simply find out by writing out potential difference across this one, that is equal to 5.4 divided by resistance of this part of the wire. We can say resistance XC. And here we have IXY, so that is equal to 9.0 resistance of the wire XY. Now from here we can write down this is 5.4 divided by resistance of this part of the wire, that will be equal to rho LXZ divided by A. And here we have this is 9.0 and this is divided by rho and LXY divided by A. From here you can see this rho we can cancel with this A we can cancel with this. So now simply we left with 5.4 divided by LXZ. This is equal to 9.0 divided by LXY. LXY is equal to 1.2. So this is 1.2. So now simply we can find out LXZ. LXZ will be equal to 5.4 times 1.2 divided by 9, and if we solve this one, our final answer has to be equal to 0.72 meters. So this is LXZ. I have explained you this one in detail so you can have better understanding of this one. Why do we use this formula? Otherwise simply I can start from here, I can plug in values and I can find the answer. So this is a way you need to understand why we did like this. Current, as current is the same in the wire, so then we can write down current is equal to V by R, and then we can solve to get the value of XC. And this question has 2 marks. The first mark you will get C1 mark if you have written this step, and if you have got the right answer you will get 2 marks. So final answer is 0.72. Second part says the environmental conditions change causing a decrease in the resistance of the LDR. The temperature of the LDR remains constant state whether there is a decrease, increase or no change to the intensity of the light illuminating the LDR. So it is given to us that resistance of LDR decreases. If resistance of LDR decrease, it means intensity of the light should increase. Intensity of the light illuminating the LDR means the light falling on LDR. Intensity of that light has to increase. So simply we can say intensity increases. It's a very important point. You need to understand how intensity and resistance, they are linked with each other. So intensity increases, simply we can write on here. The total power produced by the battery. Now in this case resistance of LDR decreases, so it means the total resistance of the circuit decreases. So we can say the I total, this is equal to 9.0 divided by total resistance. As total resistance of the circuit will decrease, it means current will increase. So as current increases, so we can say power, this is equal to I square times R. So current in this case increases, so the power produced by the battery will also increase. So we will say power increases. So we will say power increases because more current is coming from the battery. So battery is giving more energy to the charges per second. So power increases. The length XC, so that the galvanometer reads 0. So how this length will change? So if this resistance decrease, it means that the reading on the voltmeter, so we can connect voltmeter here V1, this reading also has to decrease because the reading here, if we connect a voltmeter, let's say here we have V2, reading on this voltmeter has to increase. So this reading has to increase and this reading has to decrease because the sum of these two PDs is equal to 9.0. So the PD across this one decreased. So if we connect voltmeter here, let's say V1, so the PD across XC also decreases. So the length has to decrease because V is equal to I times resistance. So we can also say this is I times rho L by A. So if this is constant, this is constant. So if V decreases, this V decreases, L also has to decrease. So we will say in this case XC decreases. So XC decreases. So XC has to decrease because V1 has been decreased. So this is how we can answer these questions. And this question has 3 marks. So if you have done the first one, you have written intensity increases, you will get 1 B mark. And if you have written power increases, you will get another B mark. And you will get another B mark if you have written XC decreases, because PD across XC decreases. Question 8, part A says nucleus P and nucleus Q are isotopes of the same element. Nucleus Q is unstable and emits a beta minus particle to form nucleus R. For nuclei P and Q, compare the number of protons. As P and Q, they are isotopes of the same element, so they should have the same number of protons, or we can say equal number of protons. And the number of neutrons, they should have different number of neutrons, or simply you can say unequal number of protons. Part 2 says when nucleus Q decays to form nucleus R, the quark composition of a nucleon changes. State the change to the quark composition of the nucleon. We have nucleus Q. It decays into nucleus R by emitting beta minus particle. If beta minus particle is emitted, then there must be electron anti-neutrino as well. Now we can assume atomic number of Q is C, mass number is A. So the atomic number of R has to be Z plus 1, because charge has to be conserved in any decay, and mass number will be A. So Z is representing number of protons, and here we have Z plus 1 mean number of proton increase. It simply means that one neutron decays into one proton. And quark composition of neutron is one up quark, and it has 2 down quarks. And proton has one down quark, and it has 2 up quarks. So if we compare the quark composition, so this one is the same. So one up quark, one down quark. So it means this one is the same. Now here we have D and here we have U, means here we have down quark, and here we have one up quark. It simply means that one down quark decays into one up quark. So simply we can say down quark decays to up quark. And for the last part, we need to state the name of another particle, not the number, that must be emitted from nucleus Q in addition to the beta minus particle, and that particle is electron anti-neutrino. So simply we can say another particle is electron anti-neutrino. So this is an other particle. So if you write on these points, you will get 4 marks for this part of the question. Part B says a hadron consists of 2 charm quarks and 1 bottom quark. Determine in terms of the elementary charge small e the charge of the hadron. So first of all, we need to understand the charge on the charm quark. So simply we can write down charm quark. Charge on charm quark is plus 2 by 3e, and charge on the bottom quark, so we can also write on here charge on bottom quark, this is minus 1 over 3e. Now we need to determine the charge on hadron, so we can say Q, the total charge on the hadron, this one has to be equal to 2 times the charge on one charm quark plus charge on one bottom quark. Now if we multiply, we will get here 4 by 3e minus 1 over 3e, and if we solve this one, we will get plus 1e. So if you have proved this one, you will get 2 marks, and this question has 2 marks. That's all for today's lesson, and we have discussed all the questions from this paper. If this video was helpful, please like and subscribe, because your encouragement is very important. And also, if you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. See you in next video.